Okay, in this video we are carrying on with our critical path analysis series, and we're going to look at float. So float is a measure of how much flexibility an activity has within a project, i.e. how much can an activity be delayed without affecting the overall completion time of the project. It is important to note that these two statements are one in the same. If an activity has no float, it is critical. Conversely, if an activity is critical, then it has no float. So that is quite an important point to remember, particularly when calculating float. It does help you speed up the process. Okay, so there are three types of float that I want to talk about in today's video. We're going to look at independent float, interfering float, and the total float. So the independent float of an activity is the float which an activity has which doesn't affect any other activity at all. The interfering float is the float that an activity has which does affect other activities but doesn't have an overall effect on the overall minimum completion time of the project. Okay, and that will become a little bit clearer when we calculate these and do some examples in a little bit. The total float is just the sum of those two. So it's how much float an activity has. An activity can have float that is both independent and interfering. So we'll see those in the calculations in a bit. So how do we go about calculating float? Well, what we've got here is we've got a general activity within an activity on our network going between two nodes. It's got a duration of t, and we've completed a critical path analysis on the network. So the start node for this activity has an early time and a late time filled in, and the end node for this activity has an early time and late time filled in as well. The total float is defined as the biggest number on the right, which is the right-hand number at the end node, subtract the smallest number on the left, so the smallest number at the start node, subtract the duration of the activity. Okay, and that will give you the float of activity X. The independent float is then the inside one, so it's the smaller number on the end node, subtract the larger number on the start node, subtract the duration. That would be the independent float. However, that can come out to be a negative number, and if that's the case, then actually the independent float is defined as 0. So I've written it as the minimum of this calculation, or 0, so it cannot be below 0. Okay, it doesn't make sense to have a negative float. And then the interfering float is going to be the total float subtract the independent float, because the total float is the sum of those two. So the interfering float is therefore the difference between the top and bottom. Okay, so those are how we calculate the floats. You just need to remember those and be able to describe the differences between the floats as well. Okay, so let's have a look at an example. So here we have a network, which we have looked at in a previous video, but this time what we're going to do is we're going to look at the calculations for the floats for all of these activities. So CPA has been done. We can see that the critical path would go across B, down E, across I, and up M. So those are the critical activities. And the way to see that is to calculate the float of these activities. So let's take activity B, for example. To calculate the float of activity B, it is the 10 on the right, subtract the 0 on the left, subtract the 10 duration. So that has a float of 0. And we said earlier that an activity that has a total float of 0 is critical. So therefore that is a critical activity. The same can be done for E, I, and M. Okay, 12 minus 2 minus 10 is 0. 19 minus 12 minus 7 is 0. And 30 minus 19 minus 11 is 0. So I is going to be 0. M is 0. And E is 0. It follows then that the independent float is also 0 because on all of those activities, the pairs of numbers are the same, left and right. So the independent float equals the total float. And then the interfering float, well, that's the difference between them, but they're both 0. So the interfering float is also 0. And that's true for any critical activity in any project. The float of the critical activities will be 0. What's also true is the float of all the rest will not be 0. The total float won't be, at least. Independent and interfering may be, but the total float is guaranteed not to be. Okay, so let's look at activity A. So activity A is here. It's got an end late time of 15 and a start early time of 0 and a duration of 3. So its float is 15, subtract 0, subtract 3. So its total float is 12. The independent float is the inside number, so 14 and 0. So 14 minus 0 minus 3. So its independent float is 11, which means its interfering float is 1, because that's the difference between them. I'm just going to repeat that for all of these activities. So activity C, 12 minus 0 is 12, minus 11 is 1, so it's got a total float of 1. The independent float, 12 minus 0 minus 11 is still 1, and the interfering float is 0. Activity D, 15 minus 10 minus 4 is 1, so it's got a total float of 1. Independent float are the inside numbers, that's 14 minus 10 minus 4, so that is 0, so it's got no independent float, which means its 1 unit of float is interfering. Activity F, 18 minus 14 is 4, minus 3 is 1, so it's got a total float of 1. Independent float calculation, we've got 17 minus 15 minus 3, that's negative 1. But just to remind you, the calculation for independent float was the minimum of this calculation, or 0, because you can't have a negative independent float, that doesn't make sense. So we're going to say that the independent float of activity F is 0, not negative 1, which leaves the interfering float to be 1. Activity G is going to be 23 minus 10 is 13, minus 8 is 5. So it's got a total float of 5. The independent float is 20, the inside number. Subtract 10, subtract 8, which is 2. So it's got 2 independent float, and then it's got 3 interfering float. H, 19 minus 10 is 9, subtract 5 is 4, so it's got a float of 4. The independent float calculation will be the same, because both start node and end node are part of the critical path, so it's got double numbers, which means it's got no interfering float. 3 left to go. Activity J, 23 minus 17 is 6, minus 3 is 3, so its total float is 3. The independent float is 20 minus 18 minus 3, that's minus 1, but we can't have negative, so therefore 0, which means all of its float is interfering. K, 30 minus 17 is 13, minus 12 is 1. Independent float, 30 minus 18 is 12, minus 12 is 0, so it's got no independent float, which means it's interfering. And finally, L, 30 minus 20 is 10, minus 7 is 3, so it's got a total of 3 float. Independent float calculation, you've got 30 minus 23 minus 7, that comes out to be 0, so all 3 of its float is interfering. Okay, so that is the calculation. Let's just look at exactly kind of what's going on here. There are some activities which all of its float is independent. So activity C and H, for example, its interfering float is 0. And that's because the start of those activities are part of the critical path. So here for C and here for H. And the end is also part of the critical path. Okay, they're there for C and there for H, which means I can start H after 10 days, or 11, or 12, or 13, or 14. As long as I get it finished by 19, it doesn't matter. It's not going to affect the overall completion time of the project. I just have to make sure I can start M on day 19, otherwise it's going to delay this. So I've got 4 units of float here, because I can start it either anywhere between 10 and 14, without affecting anything else. No other activity is affected whatsoever. It is only affecting H. The same is true for C. But there are activities which the float will affect others. So, for example, let's look at activity D. Now, activity D, it's got 1 unit of float and it is entirely interfering. So if I start activity D on day 10, then F still has its float, because I can start it on day 14 or 15. If, however, I use D's float and start it on day 11, then that forces F to start on day 15. Can't start any later than 15, because that's the late start time. If it does start later than 15, that's going to affect the overall project. But using D's float has affected activity F and its float. So the float that D has interferes with activity F, which is why it's called interfering float. And then the other interesting one I wanted to point out was activity G. This one's got some independent and some interfering. So it's got independent float because there's a difference of 2 between the 10, 8 and 20 there. So 10 plus 8 and 20. I can't leave this node until day 20 anyway, guaranteed. That's the absolute minimum. So G can start on 10, 11 or 12 without any effect on anything else. However, it can go further, because as long as it's finished by 23, that's fine, but that's going to start to affect activity L. So that the last 3 units of float that G has interferes with activity L. So it's, 2 of it is independent and 3 of it is interfering, as illustrated by the table. Okay, so that's the float calculation for that network. I've got one more example. I just want to go through this one as well. It's just one with dummy arcs, same calculation. Again, we've seen this network before. I've just turned it on its side slightly to fit it on the page. But the calculation for float is exactly the same. So we've got total float, independent float, interfering float for all the activities. So the critical activities are B, the dummy arc, which obviously isn't an actual activity, and then D. Okay, so that's the critical path. So straight away, I can write down that B has got no float and D has got no float. Okay, don't need to do the calculation for those because they're critical. So that has to be the case. Okay, C, this activity goes between a node that's on the critical path and another node that's on the critical path, which means all of its float has to be independent. So its total float is 1, okay, using the calculation, 6 minus 0 minus 5. Independent float is also 1, okay, the inside 6, inside 0 minus the 5, which means its interfering float is 0. And then F is also going to be independent. In fact, it's going to have the same calculations, 1, 1 and 0. The others are going to be interfering. So A, its total float is going to be 7 minus 0 minus 4, which is 3. Its independent float is 4 minus 0 minus 4, which is 0. So that's got no independent float, which means all of it is interfering. E, 12 minus 4 is 8, minus 5 is 3, so it's got 3 total float. Independent float, 12 minus 7 is 5, minus 5 is 0, so it's got no independent float, and which means all of it is interfering. And then activity G, 12 minus 4 is 8 minus the 3 is 5. And then the independent float, 7 minus 7 is 0, minus 3 is minus 3, but you can't have a negative float there, so therefore all of its float is interfering. Okay, so there's floats. If you have any questions, just drop them in the comments, and the next video is going to be on cascade charts. Thanks for watching.